is file number 2 for Math 107 for the homework over Chapter 5. Now we're working with determinants of matrices. Right? For a determinant, you go in this direction and multiply, and then you go, I usually make it like this, but it doesn't matter which way you do this arrow, then you multiply across the other diagonal and you subtract that. Let me clear that screen and we'll do the calculation here. So the calculation here is 6 times 8, which gives me the 48, and from that I subtract the 6 times 4. Let me write that in, what we're talking about is 6 times 8 and subtracting the 6 times 4. The answer here, of course, is 24. It is 24. And now here's the idea. If the determinant equals 0, no inverse. If the determinant is not equal to 0, then there is an inverse. So that's the difference. You look to see if that determinant is 0. If it's 0, no inverse. And why is that? Okay, because the inverse of a matrix involves, say I have some matrix A and I want to look at its inverse. Alright? There's going to be another matrix here. Well, it's a cofactor matrix, don't worry about that, what it is. But it's multiplied by 1 over the determinant of A. So if that happens to be 0, it's undefined and there's no inverse. Again, the calculation for the inverse involves 1 over the determinant. It involves dividing by the determinant. That's why it cannot be 0. So that was a 2 by 2. So you know how to take a 2 by 2. What about a 3 by 3? Again, you can only take determinants of square matrices. Square meaning same number of rows as columns. Okay, so you know how to do a 2 by 2 determinant. When you get to the 3 by 3, you expand it into a bunch of 2 by 2s, and you know how to do that problem. And here's how you expand it. Actually, you can expand it along rows or along columns, but the easiest way, and the way I want you to learn it right now, is to expand along the first row. So you put the 3 down. Right? Then in your mind, you mentally cross off the row and column that 3 is in, and you write down the remainder, you know, what's left over, and that's a 2 by 2 matrix. See, it's that little corner matrix there, 6, 1, 5, 2. Okay. Now you go to the next column, and there's your 2. But you alternate the sign. If this sign, whatever sign this is, and this is a +2, you write it as a -2. There's a rule for that, but right now just learn the mechanics. Okay. Now I cross off the row and column containing the 2, and I'm left with a 6, and a 1, and a -4, and a 2. Right? So I put those in here. 6, 1, -4, and a 2. Now I go to the next column. It's a -8. Don't change its sign. Cross off the row and column it's in, and you end up with just these terms right here. Right? So you make a little matrix out of that. And now you know how to take the determinant of the 2 by 2 matrices, so you do that. The 3 is here. Take the determinant of this. It'd be 12 minus 5. Now you have a -2. Take the determinant of that next matrix. That's a 12. It'd be minus a -4, so it's +4. And go ahead and you can finish the problem from here. So the rule for sign change, actually there's a rule that has to do with the coefficients, but I mean the position in the matrix. But if you're expanding along row 1, no change. Second one, change sign. And that's what we did here by putting a -2. No change. Now for matrix multiplication, you take, first of all, you can only multiply matrices if the number of columns in the first one equals the number of rows in the second. The number of columns in A is 4, and the number of rows in B is also 4, so you can multiply them. Right? So I'm going to erase that. We know that's true. And let's work a little bit on matrix multiplication. And perhaps I'm going to show you a shorter one here because that's so big you won't have any trouble once you know how. Let's just go 1, 2, 3, 4, 5, 6. Here's my first matrix. And I have to multiply it by something with 3 rows. So I could 10, 20, 30, 40, 50, 50, 60. It doesn't matter how many columns it has. So 3 columns here, 3 rows here, we can do it. So for matrix multiplication, you take this column and you pretend it's a block of wood or something, and you turn it sideways. And when I turn it sideways, I multiply what's in those rows, and that gives me my first element. So I'd have 1 times 10 plus 2 times 20 plus 3 times 30, and I add all that up, and that gives me my first element in my row, the first entry here in the new matrix. Then I take that column, and now I'm going to go against the second. I'm taking that row and going against the second column. Okay, so I've got 1 times 40 plus 2 times 50 plus, what is it, 3 times 60. Okay, now I'm done. I've taken the first row and I've applied it to both columns. The first column gave me my first entry here. The second column gave me the next entry. Now I look at the next row and I do the same thing. I take this row against the first column. So that will be 4 times 10 plus 5 times 20. See, matrix multiplication is a combination of addition and multiplication. 6 times 30. That gives me that entry. See, I'm building a new matrix. Then I take it and go over here against this one. 4 times 40 plus 5 times 50 plus 6 times 60. And that's my matrix. Okay, for this matrix, the first one was a 2 by 3. The second one was a 3 by 2. Remember, you put number of rows first. These two matched up, so you could multiply it, and the end result is a 2 by 2. And that's what we have here, is a 2 by 2. So when you go up to this, to do this matrix, you take this entire row and you multiply it against the first column. Then you go multiply it against the second column and multiply it against the third column. That builds you your row in your final matrix. Let's look at the size that we expect to get out. A, in this case, is a 3 by 4, and B, 4 rows by 3 columns. This matches up, and so we're going to end up with a 3 by 3. So by doing these 3 multiplications, I built the 3 rows, okay, built the 3 rows, or the 3 columns in the first row. Then you go down here to the, you take this row and you go against this column, against this column, and against this column. And now for the last row, you take this and you do the same thing. Go against that column, that one, and that one. Here's another case for matrix multiplication. Can I multiply A times B? Well, A is a 3 by 3 and B is a 3 by 3, so yes. There are 3 columns here. See, there's 3 columns here. They're going to match up, whoops, they're going to match up with these 3 rows here. So we're good. We can multiply this matrix, and when you get done, you're going to have to give a name for the result. I will give you a hint here. This was homework. Help. This is more than help. Okay, let's talk about this matrix. It has zeros everywhere except on the diagonal. It has a special name. It's called the identity matrix. Right? When 2 matrices are multiplied together that happen to be their inverses, the result is the identity matrix. So if you multiply A and B together and get the identity matrix, that means either B is the inverse of A or A is the inverse of B, however you want to state it. They are inverses of each other. This is on the test too, to understand that if you take a matrix, multiply it by its inverse, you get the identity. This is the identity in matrices. Think of this in terms of numbers. If I have 3, what's a multiplicative inverse of 3? It's 1/3. When you multiply them together, you get the identity for multiplication. It's the same idea. Okay, now we're going to have subtraction of matrices. When you subtract a matrix, you subtract element to element. I'll write you one here. So if I had 10, 20, 30, 40, and I'm subtracting a matrix that looks like this, 5, 6, 7, 8, I'll just say that. Then when I subtract, I take those that are in the 1, 1 place and subtract them. So the first entry here is going to be 5. Then you see they have to match up. The matrices have to be exactly the same order. In this case, 3 by 3 it works. Here's 2 by 2s, those work. So 20 minus 6, so I write that entry there. Okay, and you continue like that. 30, subtract the 7 from the 30, and you put that entry there, and they've got 40 minus 8 for the next one. So that was the example there. In this case, you have to do another step before you do that, and that is you have to multiply by a scalar, 5 or minus or 3 in terms of b. Okay, you can multiply it by minus 3 and then add. When you multiply a matrix by a scalar, don't have any pens here. Okay, let's say we have this one, 2, 2, 5, 2, and a minus 5, and a 1, a 1. And I'm multiplying that by the scalar 5. The 5 distributes through every single term inside the matrix. So you get a 5, then you have a 10, and a 10. You say multiply everything by 5. 25, 10, minus 25. Then I've got a 5, 0, and a 5. Okay. And you do the same with a b, and then you subtract them.